this is the loop. So the clouds over the Adriatic actually disappeared, and you can see that convection develops over Italy. So you had instability, you had moisture, but you needed something to lift your air up, and this was actually happening on the coastline of Italy and also on the islands in the Mediterranean, so Corsica and Sardinia. You can see that the convection developed in the afternoon hours. So actually your instability indices based on satellite data, which you could see already at 6 UTC, were quite correct. They pointed you to the right region in the world. You just needed some thinking, and then you would be able to conclude where the convection is to develop. So while you are looking at this air mass loop for yesterday, I will draw your attention to two more systems. The first one is the one here over the Atlantic. So this is the frontal system, Europe and developing. And the other one is the one here over the Northeast Europe, which is, as you can see, nicely developing into an occlusion with quite some convective clouds developing. Yesterday in the afternoon, I believe there was some nice, well, I'm sorry, not nice, but some serious storms developing there north of the Black Sea. The person with the blue line, could you please say something about this? This is a good idea. Can you speak up?
Oh, hello, this is Jochen from EUMeTrain. Yeah, I just wanted to point out, when we have these red stripes, it could be jets or deformation zones. So in this case, we have a big cyclone there over the east, and it's surrounded by this long stretch deformation zone. This is a zone where the winds can actually not cross that line. So it's quite nice to see that here in this image.
Yes, thank you, Jochen. I presumed it was you, but I was not sure. Yes, you're quite right. It is not a jet, because I looked at the winds. They are not so strong that they would make the black line in the water vapor, but it is a deformation zone. And the system was actually quite interesting yesterday in the morning, because it didn't look like an occlusion. There was only this small cloud head, but there was no other frontal system that would point you directly to an occlusion. Only when you start looking at the loop, then you see that it develops nicely. First, this cloud head was very interesting. Also, this one here, also a very nice feature, which is not seen always in the occlusion. So, okay, so now we have seen these two systems. We can go on and look at the situation as it was yesterday. So as you can see, the lightnings were happening over Italy. So the strongest convection happened over Italy. This is just wanted to point out that the MPEF product and the of course the nowcasting stuff products of instability were quite correct. So let us go back to this bigger image, and now I will concentrate on the system developing over the Atlantic because of one thing. First of all, yesterday I looked at the image, and then I looked at the SATREP analysis, and then a feature actually struck me a little bit, because here it was defined as a warm front band. And then yes, of course, part of this probably could be warm front band, but then I wanted to make a more detailed analysis to see what it really is, or what features it has. So first of all, as I put here the height of PV equals 1 unit, what you can see clearly is that this low here is obviously still developing, deepening, and there is PV values very low to the ground. Also, this system here doesn't seem to have such high PV values in the lower layers. So actually, this system is still to develop. It is not yet. It is not yet in its final stage. But the one over the Atlantic seems to be quite serious cyclogenesis. If we move on to the system over the Atlantic. What it looks like from the first guess, so from the infrared image, what you would guess is that you have here a cold front, also here a cold front occlusion, and here some warm front feature. There is also some clouds developing ahead of the cold front in the cold air here in this region. These clouds are developing in the thickness ridge, so actually the clouds due to warm advection ahead of the cold front. So what I was analyzing was this cold front over the sea, so over the Atlantic, and if you go on with the frontal parameter, you will see pretty much what I shown you, that you have frontal system here, so a cold front, another cold front, and the warm front here, and some clouds developing in between in the warm air behind, ahead of the cold front. From the temperature advection, and as you can see also the equivalent thickness, you can see that here you have some warm air ahead of the cold front. Behind this front you have cold advection, and there is a pair cold and warm advection here in this head of the cyclone, or in the occlusion area. So actually in this front here over the sea you have cold advection behind the front. Also, if you look at the values in the equivalent thickness chart, then you will see that your cold air is present all over here, so the cold air coming from the north and some warm air here ahead of it. Why am I showing this? Also, the jet shows some, I would say, typical features. With what I want you also to look at is, first of all, the feature over the Atlantic, which seems to be, so you have a PV maximum, advection, positive vorticity advection maximum here along this jet here. So you have definitely some development going on here over behind the cold front. I would say some cold air development here in this region, which is going to, as you will see, get more pronounced in the afternoon. And also a very interesting feature here over Ireland. You will see later on what this was. This was actually also due to upper level situation, some development over Ireland in this low. I'm sure that Jochen has also some ideas about it, but we will show the image later on. As for the frontal system over the sea, as we saw, the cold front, it consists of some cold clouds, so higher clouds with also some convective clouds embedded into it. And when you go on, I wanted to analyze the cross section, and the one I picked up was the one going across this cold front. This is the one here, because I wanted to see which are the characteristics. As I told you, this part of the front was characterized. This one was characterized as the cold front, but this one here as warm front band. Actually, if you cut through the front in this direction, what you get is this. So actually, you get pretty much cold front characteristics. If you look at since since this feature was in the end of the cross section, what you actually have is here the potential temperature lines dropping, so going downwards, and quite strong cold advection all along behind the frontal zone. So actually you have a typical cold front feature here. So the zone that you saw in the image is definitely a cold front. The warm front, so the warm front band is shifted in this image a little bit more to the east. So actually I would say that the warm front can be found here in this region. This is the warm part, but the one having high clouds, so having cold clouds, is definitely a cold front feature.